We're going to look at some more shapes now. We know that three-sided shapes are called triangles, and four-sided shapes we call quadrilaterals. Now, quadrilaterals are any shape that have four sides, so I could draw any shape I wanted. As long as it had four sides, it would count as a quadrilateral. And this is a convex quadrilateral. And it's convex because all of the corners are pointing outwards. They're all pointing out. We could also have concave quadrilaterals where one of the corners is pointing inwards. So if I've got a quadrilateral like this one, and we can see this corner is pointing inwards, so this is a concave quadrilateral. Now, we'll be expected to be able to identify the special quadrilaterals. And I've got 6 of them drawn on the board, on my board now that we're going to talk about. The first one we can see is a square. And we know it's a square because all 4 sides are the same length. I'm putting a single dash on each of the sides to show that they're equal to each other. And all 4 angles are also equal at 90 degrees. So I'm marking with the right angle symbol to show that each of those are 90 degrees. So that's a square. It's an R, not a K. And I now have a second shape. 4 sides. In this case, opposite sides are equal. So this side equals this one. And these 2 sides are equal to each other, but not equal to those. So I'm going to mark them with a double dash. Again, each of these angles are 90 degrees. And this is a rectangle. The third shape I have here, again, we have this similar setup as our rectangle. Opposite angles are the opposite lengths, the same length. And like the rectangle, the top and bottom are parallel to each other. You see, that's parallel to each other, and they're parallel to each other. And the left and right are also parallel to each other. But the left and right, although they're parallel to each other, they're not parallel to the top and bottom. So I can see I've marked it with a single arrow here and a double arrow here. Now this could be twisted around in some other orientation, so that they're the features we're trying to find, and that would define a parallelogram. Parallelogram. Okay, 3 more. Over here we have what a lot of people mistakenly call a diamond. Okay, a diamond's a 3-dimensional shape that you dig up out of the ground. This is not a diamond. This is a rhombus. And we can identify a rhombus because, like a square, all 4 sides are the same length. However, all 4 angles are not the same. The opposite angles are, so this angle is the same size as this one. And this angle is the same size as this one. If all 4 were the same, they'd all be 90 degrees, and it'd be a square we'd be talking about rather than a rhombus. So a rhombus, not a diamond. Here we have another shape. We have a pair of parallel sides. Top and bottom are parallel. They'll never meet. And this defines for us a trapezium. We can get isosceles trapeziums where there'll be a line of symmetry down the middle. We could also get a right trapezium where there would be a right angle, on 2 right angles on one side. But all of those are defined as trapeziums because they've got 1 pair of parallel sides. Lastly, we have a kite. You can recognize a kite. But what makes it a mathematical kite is that the top 2 sides are equal to each other, and the bottom 2 sides are equal to each other. Okay? There also is a line of symmetry down the middle. All these shapes are defined mathematically in the different ways we've said, and you need to be able to spell them and be able to label them accurately.
Okay, Mary, so let's have a look at this one. So solve x plus 2x equals 12. So what do you think you do first?
Okay, well, I want x on its own, so I would put x equals 12 minus 2x.
Okay, so a lot of the time we want to get x by itself, but what we want to do first is get all of these x's together. So can you see anything we can do with this? Get all these together in one place.
Oh, okay, it's 3x, isn't it?
Yeah,
so
absolutely.
3x equals 12. Oh, and so x equals 4.
Brilliant, spot on, well done.